Hi everyone, I'm Ashley. In case you haven't been here before, then I graduated from the IB 4 years ago, and since then I have been tutoring people in the IB, and on this channel then I make videos about the IB with just some tips that helped me achieve the marks that I did, and also just talk a little bit about my experience studying medicine at the moment. So obviously today we're going to be chatting about the Maths IA and a step-by-step guide to getting a 7. So in this video, we're going to be talking about what actually is the Maths IA, how does it differ from other maths assessments, breaking down the marking criteria, so really trying to interpret them and therefore create a checklist of things that you need to include in your Maths IA to score in those highest bands, and then finally steps for actually writing a Maths IA. So how to select a topic, how to plan your IA, how to actually go about writing it, and then finally at the end, I have annotated my own IA in terms of the marking criteria that I'm addressing in each section. And I know that there are a lot of example Maths IAs online that you can just Google, but I thought that me sitting down and going through it with all of you and actually explaining why I included the things that I did and what marking criteria I was trying to hit with each of the particular paragraphs and components that I included might be a little bit more helpful than just seeing this random blank, really long IA that feels kind of unattainable. Like it's just, you can't really see the structure from that. So hopefully from reading through sort of my example and talking through my thoughts during it, then it can kind of give you a sense of how you might be able to translate some of those same reflections and structures to your own investigation. So before we start all of that, I just wanted to start this video with a little bit of a pause to say that the Maths IA is very challenging, I think, for a lot of people in the IB. Maths to begin with is a challenging subject for a lot of people. I know it was for me. I've mentioned in my previous video about IB Maths that it was the subject that I struggled the most with. And I think with the IA especially, then a lot of people before doing the IB, they've never done something like the IA before. So those two things combined are kind of a recipe for struggle and difficulties. So I suppose I know that a lot of people will probably come across this video when they're Googling for help because they're having trouble with their IA. And I just wanted to kind of offer a bit of empathy and commiseration in the fact that I know that I shared a lot of stress tears when I was completing my IA, and the fact that it is a really difficult process. But just because you're having difficulties with your IA doesn't mean that it's going to turn out terribly, or that you're not going to do well, or that you're not going to get the marks that you need. I would say most people have a difficult time with the Maths IA particularly. And so don't feel like if you're struggling with it, that it's somehow a reflection on your ability to complete it or your maths ability overall, nothing like that. A lot of this, I'm going to be kind of speaking from a student's perspective. So because I graduated 4 years ago, I graduated on the old syllabus before there was AA and AI, but the course that I did is basically the equivalent of Maths AASL now. So that's kind of the context that I'm speaking from. For the marking criteria component, I am going to be bringing in a little bit of my experience from tutoring maths students, but especially towards the end when I'm talking about the process of completing the Maths IA, I'm mostly just going to be speaking subjectively from my own experience of the trials and tribulations of the Maths IA, some of the mistakes that I made that hopefully you can avoid. And yeah, overall, just kind of view this hopefully as, you know, almost like I'm an older student at your school and I've completed the IA, and I just want to pass on a little bit of the knowledge that I've gained along the way in the hopes that it might be able to help you through the journey a little bit more. I'm doing this in a little bit of a different format than usual because I think that it's going to be quite a long video, considering that I wanted to include everything in one video, so that, you know, anytime you have a question about the Maths IA, there's something in this video that you can use to address it. So I hope that you can kind of come back here as a resource. But because of that, I hope that, you know, you'll kind of settle down, get somewhere cozy, grab a cup of tea so that we can just kind of have a, well, one-way chat about the Maths IA, rather than it being, I hope you don't view this as kind of like a stressful video, look at like the immense amount of work that I have to do, or look at this like crazy maths IA that like she presented at the end. Like hopefully we can just kind of talk through how what the maths IA is, and hopefully you can take away some kind of helpful points for when you do your own maths IA, which I'm sure will be amazing as well. So here we go. What is the maths IA? So the maths IA, for those who are maybe a bit newer to the IB, then IA stands for internal assessment, which all of the internal assessments mean that they are assessments which are marked by your teachers, but then those marks are moderated by the IB markers. So the maths IA specifically, it accounts for 20% of your final maths grade, but other 80% comes from the final exams. And although it is called the maths IA, it's also sometimes called the maths exploration. So, which I think is kind of a good term to summarize what it actually is. So in order to explain what actually is the maths IA, then I thought a good way to do it would be just to contrast it with the context that most of us have for maths, which is maths exams or maths homework questions. So for maths homework questions, if we set the scene, you don't choose the question. You just open up your textbook, there's a question there, you answer it. Or you open up your exam paper, you don't get to choose your questions. It would be amazing if you did, but you don't get to choose the question. In contrast, with the maths IA, you do get to choose your questions. You get to choose your topic, any random topic you want, some economics theory, something about mountains, I don't know, any random topic, and try to find questions about that topic that interest you. You know, why, how does the slope of the mountain affect the speed of skiers going down it? Or how does the, I don't know, the height of the plant or maybe the surface area of the leaf of a plant influence its height, or something like that? I don't know. These are just random topics that I'm coming up with. But with basically, the thing is that you almost take on the role of the creator of a test, where you're the one who's choosing the questions that you're going to ask yourself. So that's great because it gives you a lot of freedom, and you don't have to answer questions that you don't want to answer, that you think are going to be too difficult, that are going to be out of your scope. But also, obviously, it's a bit tricky because it means that now you actually have to figure out what questions there are to ask. But the idea is that you find an area that you're interested in, and you figure out what questions are kind of interesting about that, and you try to use maths to answer those questions. So the other big difference between the maths IA and maths exams is that in maths exams, there's one correct answer, and there's one or only a few acceptable methods to answer that question, or to get to that answer. So if you look at the marking criteria for a maths exam, then you'll see that there are a few marks allotted for specific points in the working or in your working that they're looking to see, and then 1 mark at the end for attaining the correct answer. So because of this setup, it means that you don't have to justify anything that you're doing within the exam. They know that this question is on a specific thing. Like they know, for example, that it's an independent probability question. So if they see you put down the independent probability formula, they're not going to be shocked, and they don't need any justification as to why you did that. They're just like, oh, it's an independent probability question, so they put down the independent probability formula. Okay, tick, that's 1 mark, you know? Whereas in the maths IA, because everyone is answering different questions and there are multiple different methods which you could use to answer the same question, then it means that you have to actually justify why you're doing what you're doing. Because there isn't a template model of working out that you're supposed to be following, you have to explain, oh, I've decided to use an independent probability because this is what an independent probability is, and I can see that that applies to this situation because that is the case, then I'm going to use this formula, which can be applied to independent probabilities. So, you know, there's a lot more, I suppose, explanation and reflection that's required in the maths IA, because you have to think, why am I actually doing what I'm doing? That's going to be a recurring theme throughout this video. Why am I doing what I'm doing? Next, last 2 sort of concepts is the fact that the maths exam, obviously you have a limited amount of time, and so there's sort of a limited depth that you can get into a topic within a single question. Whereas in the maths IA, the IB suggests that you spend around 30 hours on your maths IA. So that amounts to many, many pages of working and a lot of time doing maths. So it means that you can really get in deep to a topic, and you have the ability to sort of have all of your results build on one another as you go through these multiple pages of working and justification. And then the final point is that for maths exam questions, obviously you only have limited tools available to you, whereas with the maths IA, everything is fair game. You can, in fact, you're encouraged to Google and research different types of maths, different methods, you obviously have to do a lot of research about the topic that you're going to be talking about to make sure that you're getting that correct. But, like you can research aspects of maths which are about the same difficulty as the course, but, maybe they haven't been specifically covered. And if they're going to help you in your investigation, then you're encouraged to use the internet to research the answers or research how to use those new methods. You can also use Excel. Often we're working with quite large numbers or, quite a few numbers in our maths IAs because they're longer than, your typical exam question. So a lot of people find Excel helpful. And then, sometimes it involves photos, and sometimes you're gathering your own data. So you need equipment to gather that in order to, get the data that you're going to be analysing in your IA. So that's kind of an overview of the maths IA. And I hope that you're seeing a little bit at the moment some of the parallels between the maths IA and some of the other IAs that you have either done or will do, particularly the science IAs. So the whole purpose of a science IA is to find some question in the world that you would be interested in investigating and using the scientific method to try and find the answer to that question. In the same way, the maths IA asks you to look at the world, try to find a question that you're interested in answering, and use maths as a tool to try to answer that question. So both of them are trying to get you to use your own initiative to find something that you're interested in looking at and investigating about the world. And they're both trying to get you to use the tools of their respective subjects as a means of investigating the subject or investigating the topic more. Investigating the topic that you're looking to investigate in your IA. So I think that was helpful for me to kind of think about the mindset of the markers. And also my science teacher always used to tell me, don't worry about the day when you're doing your experiment, because it doesn't matter if you get bad results or like results that don't match your hypothesis. In some ways that's even better because it gives you so much to reflect on in your discussion. And I would say the same thing for your maths IA. Obviously, if you can't even get started with your maths, then that doesn't give you much to reflect on. But if you're having difficulties and challenges and things that you're not understanding and you need to change your method halfway through, then that's amazing for your maths IA, because that's all builds into the reflection and the justification of what you're doing to say, oh, I tried this approach, but it didn't work. So then I shifted to this, So that's kind of a similarity as well between the maths IA and the science IAs, is that the markers are far more concerned with your thinking, how you're justifying the things that you're doing, as opposed to being concerned with you getting the correct answer or one specific answer that they're looking for. So that's an overview of the maths IA. So now we're going to have a little look at the marking criteria. So this is where it gets quite dense. So, I mean, I would encourage you, if you have the marking criteria with you, to whip it out. Otherwise, I'll have it on the screen, so that's fine. But I think it's important before you kind of jump into the maths IA, but also any IA, this is a good, I suppose, exercise, is to almost summarize the marking criteria and figure out from what they're saying there, the checklist of things that you have to include in your IA in order to sort of tick off and make it undeniable to the marker that you've satisfied those marking criteria. So I'm going to go through each of these marking criteria one by one and consider just that thing. What's the checklist of things I need to do to satisfy this criteria, and how and where in my IA will I include this? So it's one thing to know what to do, but it's another thing to actually know where that fits within the broad scheme of your IA. So that's what we're going to do. So starting out with Criterion A, communication. So there's 4 marks allotted to this criterion. The first adjective, so on the left-hand side here, I have sort of summarize the key terms or the key words from the marking criteria, which is normally written out in full sentences, but these are just the key terms. And then on the right here, I have kind of the interpretation of what they mean by these words. And this is based on my own perspective, but also what my teacher told us when we were doing the IA, and she was kind of explaining to us what the IA was and how to achieve these marking criteria. So first up, we have coherently and logically developed. And what this basically means is that one section in your IA has to lead to the next one. So when I'm thinking about the IA, I tend to think of it as almost the story of how you got from asking your initial question and choosing your initial topic all the way to achieving the aim of your investigation and answering that overarching question which you've set yourself. So it should be this almost linear narrative of all of your reflections, all of your strategies, all of the work that you did along this journey of the investigation. So because of that, it should naturally flow in terms of the fact that if you've changed strategy, or if you're suddenly including some new working, or you're including some new context, then that should all link logically in terms of how it came to you when you were doing the maths investigation. So normally it would, if you're introducing like a new concept, it would be because some previous approach or some previous concept was insufficient to answer the question, or you were having some trouble with that method. So then you would say, oh, I was having trouble with this method that, like, for X, Y, and Z reason, therefore I changed approach to this. So it's okay to sort of acknowledge, almost like the talk essay, you can acknowledge the changes and the shifts in your thinking and approaches as you're going through in order to create this smooth transition between everything that's happening. There should also be a smooth transition between the different types of presentation of information in your IA. So a smooth transition between your written out paragraphs, your mathematical notation, such as, just formula and numbers and things like that, and also the other presentations, so tables, graphs, all of that kind of stuff. I can't tell you how many IAs I've read and marked, which they're going along, I'm reading their paragraph, I'm like, okay, yep, this makes sense. And then all of a sudden there's this random table in the middle of the page, or there's this random graph. And I'm like, what is this graph? I have no idea what this is referring to. So please, for the sake of your markers, it obviously makes sense to you because it's your IA, but you should always reference the figure number of your tables and your graphs in your paragraph. So say, I then carried out this formula, insert formula here, the results of which can be found in figure 2. That just makes it so much, that's the kind of coherence that they're talking about here, in the fact that I can see where everything that you've written down fits into your broader investigation. Having a random unlabeled table that isn't referenced back to the paragraph is not very coherent. So that's kind of one aspect to it. Also, when it comes to your introduction, then there are kind of just 2 structural things that you have to include in your introduction in order to make it logically developed. So first, you start out with your rationale of like why you chose the topic that you chose. So there you're going to insert a little bit of your personal engagement. Why was this topic personally engaging for you? Why is it an interesting topic in general for the world? And then you're going to talk about your aim. So within this topic, what is the overarching question that you want to answer? So that's coherent and logically developed. And then we have well organized. So there's going to be an introduction, that's this one here. You're going to have a conclusion at the end. And then in between, you're going to have a body. You don't have to have a heading that says body, but that's just like the bulk of your essay in between. So that's just like, you should have headings for introduction and conclusion. And then in the body, I would suggest headings which outline the kind of steps that you're doing in your process at each stage. You'll kind of see them when I go show my IA at the end. I think you can get like an example of how you might use those headings. Next, concise. Pretty self-explanatory. Don't include information that isn't directly relevant, or if there are things that you can put into your appendices because they're very lengthy, then put them into your appendices. So the deal with appendices is that your IA should be able to be understood on its own without the appendices. But if you have sort of extra information that you can or want to include, then you can put that in your appendices. So often you'll put like the full working out or the full sort of results in your appendices, but you'll put a sample equation or a summarized table of the results in your actual IA. Obviously, this all depends on how much data you're processing and how much space you have in your IA, but that's kind of the deal with appendices. So if there's anything that you want, anything in your sort of like paragraphs that you want understood by the marker, you can't just say, oh, like I did this, see Appendix 1. If it's something that's critical to their understanding of your method, then you have to put that in your actual IA. But if it's something that, you know, is not, maybe it's like the intermediate step in between this step and like the next thing that you're going to do, then you can put it in the appendix because it's not critical to them understanding your method. Have a little drink. Yes, so that's the appendices. So that can help with being concise if you need it. And then complete. So this just means that you have properly explained all of the steps that you've done. So you've not just sort of jumped from one thing and then all of a sudden have all of these new numbers and you haven't explained how you've gotten there. And then also how you have met, how all of your steps have met the IA's aim. So that overarching question that you were trying to answer at the beginning, is your IA complete in the sense that everything that you've included in the IA is working towards answering that overarching question? So that is the communication criterion A. Oh, I also have why here because this is like a little running theme of why are you doing the things that you're doing? You're doing them in order to answer your IA's aim. So everything should come with a justification of, I am doing this. Why? Because I want to meet my IA's aim, which is insert here. So criterion A. Now we have criterion B, which is mathematical presentation, and there are 3 marks awarded for this criterion. The first is for appropriate mathematical language. So this includes a couple of things. Firstly, using correct notation and terminology. So basically, don't call something that's not a normal distribution a normal distribution. If it's not an independent probability, don't call it an independent probability. So basically using those technical terms correctly is what they're talking about here. And same with notation, just like, you know, using like function notation correctly or using like sine or cos or something, like writing that out correctly is basically what they're saying. Always define your variables. So appropriate mathematical language means that every time you introduce a new variable, you have to say what that variable represents. So again, this is like a very common thing. I even had it in my IAs at first before I got feedback from my teacher, where I just had like random X's and Y's, which I just introduced because that was the formula without explaining, oh, the X is this thing in my, you know, investigation and the Y is this thing in my investigation. So you need to define what your variables actually mean. Otherwise it's super confusing to read. And then finally, oh yes, if you're typing your IA up in Word, then you have to, whenever you're typing out numbers or like working, then you have to use the insert equation function on Word. You can't just type it out with your keyboard like 2 and then X written like a normal X. You have to use that insert function tool so that you get like 2 and then like the mathematical X. That's just a case for everything. It's a formatting thing. It looks very nice when you do it, but it is a bit of a pain. So just keep that in mind. So then also you have to define key terms. So in addition to not using terms like normal distribution, standard deviation, independent probabilities, in addition to using them correctly, you also have to define them each time you use them. So you'll see this in my IA later. If you're working with a normal distribution, you have to give a definition and say a normal distribution is this before you start talking about it. So that's very different from like, say, a maths exam. And then you have to explain how that definition applies in the context of your IA. So say, okay, a normal distribution is this thing and this thing. These are the characteristics of a normal distribution, and here is how those characteristics are present in the context of my investigation. Or, you know, this is what standard deviation is. This is what standard deviation means in the context of my specific investigation. So you always have to give the kind of dictionary definition and then give the contextualized definition. And then the final point for this marking criteria is multiple forms of expression, that's mathematical expression, where appropriate. So this includes things like using different formulas, diagrams, tables, charts, models, like all of these different ways to communicate your mathematical exploration. If you're using tables or charts or diagrams, then you have to correctly label them with titles up the top, so figure 1, and then with a descriptive title, and then also with axis titles if you have a graph. But it should be noted here that full marks can be achieved with only one form of representation if it's appropriate. So the big thing about these different multiple forms of expression is that you have to choose the form of expression which is appropriate for the type of information that you're trying to express. So I can't think of an example right now, but let's say like the difference between a line graph versus a histogram. They're sort of appropriate for different contexts. So you have to look at the data that you have and think, what's the most appropriate way for me to present this? And does this visual representation actually add anything to my communication? Or would it be easier for me just to explain my findings in words? That's kind of what they mean by appropriate. Like, is this the most appropriate visual representation of your findings? So that's mathematical presentation, so Criterion B. Then we have Criterion C, which is personal engagement. And I think this is the one which gets made fun of most by people, but I think it is actually pretty important. So obviously the part which gets made fun of that like, oh, I have to show my personal engagement is this first part here. So engage with the exploration, specifically have your aim address a personal interest. And this is addressed in your rationale. So these are just easy marks. Have some personal story, have some personal connection with the IA topic. Hopefully, if it's a topic that you're curious about, there's a reason why you're curious about it. So you'll just naturally have this personal engagement, or personal interest. So there's, just remember to include that in your IA. But that's only one component of personal engagement. The part that a lot of people don't remember is that there's this part as well, which is the fact that they're assessing for personal engagement based on whether you've made your IA your own. So this means thinking independently and creatively. So this could come out in your topic, in your aim, or in the methods that you're using. So just the fact that you've kind of chosen a kind of interesting perspective on a topic, or you can tell by the way that you're justifying the things that you're doing that it's you who came up with this method to answer these questions, and it's you who is interested in asking these questions to begin with. Similarly, presenting mathematical ideas in your own way. If you've explained the concepts, if they can tell that you've explained the concepts in your own words, that's why it's so important to give the dictionary definition, and then give the definition of things in context of your IA. And then also when you're justifying what you're doing, again, show that you actually understand what you're doing by the fact that they can tell that you've written this in your own words, and that you've created your own visual representation. So you've created your own graphs based on this, and you're able to explain and unpack those graphs. Also, for my IA, then I collected the numbers that I was actually using within the IA. And so that also showed personal engagement, because to summarize, I did it on bowling. So I bowled a whole bunch of games and I collected my scores, and I was analyzing my scores within my IA. And so that obviously shows personal engagement because it's kind of creative. I needed to go out and I needed to play all of these games myself, and obviously it's mine. So there's that personal attachment to it. So if you're collecting your own data, then that's also quite a good way to show your personal engagement with the topic, because it's not just some random numbers that you found online. It's your own thing that you've created. And then, yes, the big note about personal engagement, and the reason why I think it shouldn't be overlooked as a marking criteria, or think oh, that's just easy marks to get, is the fact that there has to be evidence of your personal engagement in your actual IA. So it's not enough for your personal engagement to be obvious to your teacher. Obviously, through talking with your teacher, they're going to understand that you've come up with these ideas and that you're interested in it because of this, this, and this. But your personal engagement has to come through in your IA itself. So to this external moderator who's never met you, who doesn't know you, who doesn't know your interests, and doesn't realize the cool, quirky ways that you figured out to solve the issues in your maths IA. So that's why you have to really kind of make it obvious throughout that like, oh, I thought about this, I considered these ideas. However, I realized that no, instead I needed to do this. And like, then I approached it in this way. So kind of make it clear when you have, I suppose, had this almost creative or independent thinking where you've needed to address some sort of issue, or you've almost preemptively recognized an issue and therefore designed your maths IA in a particular way. Needs to be in your IA. You can't just chat about it with your teacher and be like, personally engaged, because even though your teacher is marking it, then the external moderator is moderating those marks. So that's personal engagement, 4 marks. And then Criterion D, reflection. And Criterion D, and I'll just flick forward, Criterion E is use of mathematics. You'll see that there's some overlap there in that if you reflect effectively, you're also going to be demonstrating your use of mathematics and your understanding of mathematics. So just to go back to reflection, reflection boils down to 2 major questions. Again, why? Why did you do what you did? So in a lot of maths IAs that I read, then people will just chuck in formulas and be like, oh, I was like looking at this and this was my aim and da 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 da, and all of a sudden we have a sequences and series formula. And I'm like, why are we using sequence? Why did you choose sequences and series as your method? What are the variables here? I don't understand what's going on. So you need to kind of, before you do anything, have a little justification to be like, I was thinking about this issue and I saw that sequences and series would be the best way to approach it because, based on this website that I've read, then I predict that there's going to be, an arithmetic sequence, and therefore I'm going to use sequences and series, whatever the method is. So you need to justify what everything that you have written down. You need to have some sort of justification as to why you're trying to do that. Also, what did you learn from it? So this isn't just like, I learned to love maths or I learned that, probability isn't that hard. No, it's more like, what did you learn based on the implications of your results? Looking at how you used maths and what you were able to produce through it, how does that change your conception of this topic? How does it change your conception of that overarching question that you were like asking at the beginning? Has it challenged your thinking in any way? That's kind of the 2 major questions. So I've broken down just some like smaller ones that you can ask yourself throughout. So again, explain what you're doing links to the IA's aim. That's why you did what you did. Discuss the strengths and limitations of the approaches that you used. Again, why are you doing it? Because it's a strong approach, hopefully. Compare different mathematical approaches to explain why you chose the one that you did. So it's okay to say like, I considered this other approach, however, it wouldn't be appropriate for X, Y, and Z reason. How did you decide based on preceding steps or findings what to do next? So kind of as you're going through the investigation, did your, I suppose, anticipated approach or what you were planning on doing change at all based on some of the findings that you got initially in like the initial steps of your investigation? What are the implications of your results in your chosen context? So that was what I was talking about before. Like, how do the results that you've found impact the context that you set up in your introduction? And, how does that change your perspective on the world? And what should we do as a result of your results or your findings? And then comment on what you've learned, same as what we were talking about before. Note, yes, reflection throughout is required for the top marks. So in comparison to a science IA, where you kind of have the big discussion at the end where, initially you're just objectively presenting everything. And then it's at the end when you're like, I'm a terrible scientist. I made all of these mistakes. This is why my results are terrible, blah, all of that sort of stuff. You kind of leave it all to the end. In the maths IA, then you want to incorporate that throughout your exploration to say, like, I chose to do this step. I understand that there are these limitations associated with that because I am working with this type of data, for example. However, I chose to proceed because, of this other reason. So kind of acknowledge the limitations of what you're doing throughout and continue to reflect on why you're doing what you're doing. Basically answer all of these questions as you're doing things. Again, it's kind of showing your reflections and almost your mental journey throughout the IA. And I put a little notebook here because I think it's quite a good idea to keep either a physical notebook or just a Word document, which has these kinds of reflections. I'll show you later how I like annotated my documents with these reflections in order to keep track of them, because it's really easy to forget these later, and you'd be surprised at how easy it is to forget why you did what you did. Like, you'll open the document the next day and be like, what are these numbers? What was I doing? I don't understand any of these formulas. And then you'll be like on a mad goose chase through your documents to try and connect the dots of like where these random numbers came from. So always as you're doing things, and it'll help you so much when you're writing your IA later, if you even just write out in like super colloquial terms why you're doing what you're doing, you can translate that into formal language later, but just having that like explanation of where your head was at when you were doing those particular things helps so much when you're writing the actual IA. So that's Criterion D, and now Criterion E is the use of mathematics. So it has 3 aspects to it. Firstly, the extent to which you use mathematics in the IA. And what this is really asking is this actually a math IA? So a lot of times people in their initial suggestion of topics will come up with things that are actually physics or economics IAs with a little bit of maths in them. So they're actually more so to do with other subjects in the IB. I wouldn't worry too much about whether you're doing this when you're trying to select a topic, just because your teacher will pull you up on it very quickly. If you ask like, oh, is this a good topic? They'll be like, that's not a maths IA. So I wouldn't be too worried about deciphering it yourself, but just be kind of aware that that's an issue. You want the focus to be using maths to explore these things, not just using subjects which use maths as a tool sometimes, like economics or chemistry or physics or something else. The maths should be relevant and correct. So when they say relevant, then what they're really looking for is math that is used is the type of maths used suitable for the way it is used. I didn't phrase that very well, but like, given the context that you're trying to use the maths in, is the type of maths that you've used relevant or appropriate? Kind of like what I was saying, if you are trying to calculate a percentage, you're not going to randomly use a probability formula. Or maybe a more realistic example, if you're working with, let's say, conditional probabilities, you're not going to use an independent probability formula. So that's what they kind of mean by like suitable. Or even, let's say if you have a data set which has a lot of outliers, you would use the median rather than the mean in most contexts because of those outliers. So it would be more suitable to use the median. So if you use the mean, if you had some justification for it, then it would be fine. But if you didn't have any justification, then it maybe wouldn't be considered suitable. So that's what they kind of mean by relevant. And then also correct is very interesting, because the maths can be correct even if occasional minor errors occur, if they don't detract from the flow of mathematics or lead to an unreasonable outcome. So unlike in a maths exam, where if you make a mistake in your maths, then you'll usually get a mark taken off for it. In the maths IA, they're not really concerned with like really small algebraic errors or anything like that. Obviously, do your best to not do them, but overall, they're more concerned with your general methodology, your reasoning behind that methodology, and whether your outcomes, whether you're able to assess personally if the outcomes that you get are reasonable for the context in which you're performing them. Like, does it, for like whenever you're doing questions and then it's like, if you're trying to split up people into groups, and then your answer is something like, oh, you get 1.23 people per group, and then you have to say, okay, well, that might be the answer, but I'm only going to put one person in each group because I'm not going to cut a person so that I can get 0.23, of a person. So that's what it kind of means in terms of like unreasonable outcomes. So yeah, your maths, I'll say this afterwards, but demonstrated a thorough knowledge and understanding throughout the work. So that basically means that you have to include all of your working. You've explained and justified your approach, so you can see how this kind of has a symbiotic relationship with the reflection marking criteria. Even though only 3 marks are allotted for reflection, then a lot of things that you might think are reflection help to support the marker seeing your use of mathematics. because you've justified everything based on how you reflected and realized that you needed to use this particular method. Yeah, and so the correct answer is not enough. You must show all of the steps you took to attain it. So you can't have random numbers coming out of nowhere. You have to show all of your steps. And what I was going to say is that you have to use, I don't know if I put this here, but overall, the maths that you use has to be commensurate with the course. That's kind of a phrase that is thrown around. And I wouldn't be too concerned about it because, again, your teacher will pull you up pretty quickly if the maths that you're using is too simple for the course, and they'll say, you have to include some more complex maths. But if you're using things which you found in your textbook, then in general, it's going to be commensurate with the course. And also, you don't have to, based on this, the maths that you use doesn't have to be that complicated. Sometimes, I know for me, I wasn't expecting to use such complicated maths, but like later down the line, I got myself into a pickle with the IA. And so I had to use this formula, which wasn't from the course, and I had to research it and everything. And so then I had to use some more challenging maths. But overall, it's not necessary based on these marking criteria to choose the most challenging maths from the course. Because in the IA, what they're really more so assessing is your justification and your understanding of applying maths in context, and your ability, your creativity to come up with a question and an aim. So yeah, I suppose that's just to kind of say, don't pick a topic that based on the fact that you think it will need really hard maths to analyze, or don't purposely make the maths in your IA really hard. I always kind of say to my students that the type of maths that you use should be guided by the questions that you're trying to answer. So whatever maths is helpful, whatever tools, whether that's Excel, whether that's your graphing calculator, whether that's, some other mathematical tool that you have at your disposal, whatever helps you answer the questions, then that's what you should use. So don't sort of purposefully try to manipulate the maths so that it's harder, because you won't gain any extra marks for that alone. So that's the end of our marking criteria overall. And oh yeah, the other thing I wanted to say is if we go back up here, then we can see that the use of mathematics accounts for 6 of the marks in the IA. Overall, all of the others account for much more. So even if you got very low marks in your use of mathematics, if you manage to make your working coherent and logical, if you use the correct sort of formatting and presentation, and you gave all of the definitions of the mathematical terms that you were using, if you showed personal interest and also had a kind of interesting approach to it, and if you made sure that you reflected on what you were doing throughout, then you would still get a really great mark overall, even if you got a low mark in the use of mathematics. So I think a lot of people get kind of tied up or worried about, like, I don't know how to answer this mathematical question, like I don't know what I'm doing, like this is too hard. But even if you're struggling with those things, as long as you make sure that you're doing well on sort of the almost like the ribbon on top, like the packaging of the maths that you're doing, then you can still get a really good mark for your IA. So that's just kind of like, obviously you're focusing on your mathematics throughout because it's a maths IA, but there's all of this other sort of reflection and communication and presentation marks that you can also pick up that can kind of save you if your maths is getting a little bit dicey. So that's kind of the end of the objective part of this video, where I'm just going through like what it is and the marking criteria and all of that. So now I'm going to have a bit of a chat of just sort of like my whole process of going through the IA, and from start to finish, how I figured out my topic all the way to writing the final thing. So we're going to start with selecting your IA topic, which I know is a big issue for a lot of people, because it's really difficult to just choose a topic, like a random topic, and figure out which one is good and what's going to make a good IA and all of these things. So I kind of have these steps here, which is what I did for my maths IA. So the first one was to find a topic. And the way that I did this is that I kind of used Google and a little bit of my imagination in 2 ways. So the first way was to pick a topic from the textbook. So let's say sequences and series, or probability, or statistics, or functions, or whatever, and just put in real life afterwards, or applications, something like that. And then it will come up with a whole bunch of results of how sequence and series are applied in real life. And that can give you like a whole bunch of random topics. Obviously, if you're particularly interested in a topic in your textbook, this could be a good approach. However, it's a bit tricky because you'll just get a whole bunch of random subject matter. And so it might be harder. You'll be sifting through a lot of results before you find one that you have personal engagement with. So that's one approach. The other one is just to type in mathematics or maths in, and then insert topic that you're already interested in here. So I put in ballet, but like I would just do this, you know, rapid fire. I'd be like maths of food, maths of, I don't know, buildings, maths of dance, maths of, I don't know, knitting, maths of juggling, you know, like I would just have all of these things that I was interested in, and then I would just put maths of blank, and then insert the topic that I was interested in. And then that's kind of a really good litmus test to see, is there actually any maths behind these topics? Because sometimes I would type in, let's say like maths of food, and then there would be like no legit sources that would pop up, and I'd be like, okay, there's probably no maths IA to be found under this topic. Whereas like you can kind of see there, if I put in mathematics of ballet, then a kind of official looking PDF comes up with the mathematical modeling of ballet. And so that could kind of, just as a quick sort of, I guess, test of whether this is a topic that I should investigate more, that would tell me, okay, well, there is at least some mathematics, someone somewhere has already looked at mathematics in ballet. So there might be something also for me to look out there. So the big thing that I see students doing when they're Googling for their maths IA is they'll say like, they figure out a topic that they are interested in, and then instead of putting like mathematics in ballet, they'll just type into Google like ballet maths IA, and that will usually not give you very good results, because despite me saying, oh, there's lots of like maths IAs out there, obviously like there's this infinite number of topics and only in comparison a relatively small number of IAs available online. So chances are you're not going to find an IA on that topic. And I think it just is then disheartening, because you're like, oh, I can't find it, like this is a bad topic or whatever. When it's not, it's actually good, because then it means that it's kind of original. And also, even if you did find an IA that was on that topic, then it might not really be the angle that you're interested in looking at. Like I know for, I don't know, just for like probability topics, just because my IA was on probability, so I always think of that, then like there's, even if someone else, my final IA, like I said, was on the probability of bowling, even if I found someone else who was doing bowling, they might have done like assessed bowling from the perspective of functions, or from the perspective of sequences and series, or I don't know, some other topic, right? So even if I found a maths IA that was on bowling, then like it might influence my thinking too much and make me start to go down the same track as that person who did the maths IA. So I think it's just easier to stick to, like you'll get better results if you just stick to Googling like general mathematical, like mathematics applications, or like specific topic applications in real life. Rather than trying to base your IA off some other student's IA. So that's how I kind of chose my topic. I'll show you one of my failed IA topics was on juggling. So that's how I found that one. So the mathematics of juggling is what I typed into Google, and I found all these results. And then I found my final IA topic the same way. I was like the mathematics in bowling, and then I was like, I'm kind of interested in doing probability in bowling. Okay, is that there? Okay, and then I found some results. So yeah, you can do that. So after you find your topic, then you want to choose an overarching question that you're trying to answer about that topic. So with my IA, for example, my overarching topic would be bowling, and then my overarching question would be like, obviously we'll get to this later, but I would be like, okay, I'm interested in doing probability. What specific probabilities am I interested in looking at in bowling? Is it the probability that I win a game? Is it the probability that I score above a certain score? Is it the probability of, you know, like there's an infinite number of questions that you can answer around probability in bowling. So you have to kind of pick the one that you're the most interested in. And then step 3 is to create a list of the smaller questions you would need to answer this, you would need to answer to address your aim. So if my aim is to figure out the probability of me scoring above a certain score in a game of bowling, then I would need to figure out my probability. So my little list of smaller questions is, what is my probability of getting a strike? What's my probability of getting a spare? What's my probability of getting, a 9 or a 8 or whatever the other scores are? It's been a while since I've done my IA. And maybe I would want to, and then start to think about like other ways that you could expand it. So, if, my first probability is, I get above a certain score once, maybe like another question that I could ask is, what's the probability that I get above that certain score twice, something like that. So, just kind of start brainstorming these smaller questions that you could ask, almost like, what are the steps that you would have to take? What are the smaller questions that you would have to answer that overarching question? And that is kind of your personal engagement of figuring out your approach to answering that big question. And then step 4 is describe theoretically how you would approach answering these questions, those smaller questions. What calculations would you use? What formulas would you have to invoke? How does it apply to your IA's context? And then ask your teacher for feedback based on this. So this was kind of how my school went about structuring our IA prep, was that we had to submit these IA proposals, which were basically this. We had to, basically have a step-by-step guide to our IA already with a structure before we'd even started writing it, to kind of say, okay, these are all of my subheadings with like the smaller questions that I need to answer. And then I'm going to use this formula. I'm going to use the independent probability formula. I'm going to use, I'm going to create a probability distribution. I'm then going to analyze it. I predict that it's going to be a normal distribution, so I'm going to be able to analyze it this way, all of these kinds of things. So this is the really critical step, because this is going to show you whether this is a viable topic for your IA. And what you're looking out for is whether there's enough depth there to be able to base an entire IA off it, and also whether the questions that you're answering are kind of logical and, again, link back to the aim or the overarching question that you're trying to answer. So assess that overarching question. Is that overarching question actually interesting or actually something that you want to answer? And then do each of the smaller questions actually link back to it? And then finally, do you actually have an idea of how you would go about answering those smaller questions? Because sometimes you ask these questions and you're like, I don't even know where I would start with this. And even after reflecting on it for a long time, you're like, I still don't know. So maybe don't do an IA topic where you have big blank spaces under these potential questions where you have no idea where to start in terms of the working. And that's why I kind of said, ask your teacher for feedback based on this, because I think this is a good time, at least at my school, this was like the first round of feedback that we got was on these proposals, so that we could get like the green light or not to start our IA, because it kind of gives your teacher a good overview of like, could this potentially work as an IA topic, and what are your plans going forward? So that's selecting your IA topic. And also just want to mention here that you will go through this process with lots of potential IA topics. I kind of mentioned that I had like rapid fire Googling of like maths of food, maths of water, maths of all of these things. And in that process, you'll reject some, but also your teacher will reject others when you thought you were on the right track. So I'll share afterwards about my failed IA. But yeah, like oftentimes you'll think like, oh, this is an amazing topic. I'm so excited to do it. Like, this is so great. And then you'll share with your teacher and they'll be like, no, that's not a very good topic. Try again. And you'll be like, but I just spent hours researching this and I drafted up this whole proposal and I was so excited about it. Like, what am I supposed to do now? And you just have to kind of let it go. Like, try not to get too attached to any IA topics before your teacher has approved them, because at the time, it can really feel like a setback. Like, I just spent like 5 hours researching this. Why did they reject my topic? But when you think about the 30 hours, and often more than 30 hours that you're dedicating to your IA overall, then to get a not so great topic rejected at the start is actually going to make your life way easier earlier. So your teacher is really doing you a kindness if they reject your topic, if they don't think that it's suitable. So don't worry, it's part of the process. Most people have been there, either rejecting lots of topics themselves or having their teacher reject their topics. So, above all, listen to your teacher's feedback and trust their judgment, because they have seen a lot more successful and unsuccessful IAs than you have. And so they know what the IB wants, and they can kind of see into the future what issues you're going to run into with an IA before you can see that. So I would just kind of trust what they say, and it's kind of like this. So I'm going to share my unsuitable IA topic, and this is one at the time where I was like, this is a great topic, this is so amazing, I'm so excited to do this. And then I shared it to my teacher and she was like, that's not a good topic. And at the time I couldn't understand why, but now after tutoring for a few years and looking back on it, I'm like, I'm so glad I didn't do that topic, because it just would have been so challenging and hard to make a good IA out of, that I was happy that I didn't do it. So the main issues with it was that there was insufficient depth, so I wouldn't have been able to make enough content out of the IA, and there was also no clear aim. So I'll just share my proposal with you now. So this was my initial proposal for the mathematics of juggling. So I was into juggling at the time, and so I thought, oh, the maths of juggling, that's a bit fun. And yeah, so I talked about my personal engagement with it. And then when I searched up the maths of juggling, I got all of this cool notation to do with it. And it's the site swap notation or space-time diagrams. And there's all this stuff to do with the gradient of the space-time diagram, and the space between your hands, and the distance here and the height of it. And so I thought, oh, wow, this is really great. I can think about it from the perspective of me improving my juggling, and therefore using these diagrams to analyze how fast you can throw the ball, and hence how high you should throw it. Basically, when you're starting to juggle, you learn at first and you're super slow throwing the balls, but then eventually you can speed up. And so if you need to throw the balls slower, then you need to throw them higher, because you need to give yourself more time to have the ball in the air so that you can catch it more slowly. So I was like, oh, I'll figure out how long I want one beat to be, one change of the ball, change of the ball, change of the ball. I'll use the diagram to figure out the speed, and I'll sub it into this, and I'll do all of these things. But the issue was that only has one answer. If I figure out how fast I want one beat to be, I find the speed from the space-time diagram, I sub it into this formula, and then I graph a parabola. That's probably max 2 pages of working out. So that's not long enough or deep enough or complex enough for a maths IA. And it took me I probably spent 10 hours researching and trying to understand these juggling diagrams, but it just wasn't going to work as an IA. And also the aim overall just doesn't make sense, because the whole purpose of juggling is that it's a performance. It's aesthetic, whatever, it's an art form. So analyzing how high you can throw the ball so that you can juggle properly, it doesn't really make sense, because what you should really be practicing is to be able to juggle better, so that you have, you want to be able to have variety in how high you throw the ball and the different patterns that you throw the ball, because that's the whole purpose of juggling, is to develop new skills and to be able to juggle in different patterns and in different speeds so that you can entertain an audience. So overall, just the aim didn't make sense within the context of juggling. And then also the questions that I was these smaller steps or smaller questions that I was asking myself, they wouldn't have provided me with enough content for the IA. I also had these other ideas of oh, I could look at the sequences and series, there's something with the notation, oh, I could find the nth term, and I could videotape myself to make sure that I'm throwing the ball at the correct height to get it to be the correct speed, and therefore for it to land at the same point as this theoretical diagram. It's not adding anything to the exploration mathematically. I'm kind of testing something with a video, but I'm not adding any further mathematical exploration to my IA by doing that. So you can see that doesn't really add anything. Yeah, my applications. yeah, that doesn't matter. It doesn't add anything to the exploration. So I hope through sharing my failed proposal at an IA that firstly, it makes you feel a little bit better if you have had an IA rejected, because we've all been through it, and like you'll find a better topic, and your teacher will approve that, and you're going to go forward, and it's going to be great. Even better, I'm sure. Like if I had done an IA on this, it would have been terrible. But also, like I hope you can kind of see some of the mistakes that I made, and hopefully not make them yourself. So when you're writing out like this plan, it looks like I've got like all of this research, yes, all of these diagrams, yes, it's so mathematical, but when it comes down to the actual maths I was going to do, 4 steps is all I had. That's not enough for an IA. So when you write out your steps, then think about that. Think, is this enough to fill up an IA? And then, yeah, like really reflect on your aim. Be like, is this relevant to the context that I'm talking about? No, it's not. So yeah, try and make an aim which is actually relevant to the context and the questions like that you want to answer overall. So that's my failed IA. So going back to IAs. Now, once you've selected your topic, you actually have to write your IA. So this is just going to be me kind of talking through how I approached the actual writing process. So at this point, when I had my actual, proposal for my bowling IA, then I had like a very detailed structure and everything. Actually, I will just stop sharing for a moment and I'll just get that open. Sorry, I forgot to open this beforehand. So for my juggling one, for my bowling one, after my failed juggling one, then I had a new proposal that was actually acceptable. Yes, so this was my bowling proposal. So you can see that I have, specific personal engagement there, like I did for juggling. And then I have applications like I did for juggling, but you can see I have a much more detailed plan of what I'm going to do. And there's actually a lot of content here. So probability of winning against a professional bowler. I have all of these steps of like how I'm going to create this score, how I'm going to collect this data. I'm going to collect this data from online. I'm going to create histograms to find the probability distributions. And I'm going to I think that they're going to be distributed normally, but even if they're not, then I'm going to work with the central limit theorem. So like I'm already predicting like what issues I could run into with my IA and figuring them out. I'm going to find the average and standard deviation. I'm then going to use a t-test to work out the probability that I'm going to beat the professional. So you can see this is already so much more expansive than my initial application or proposal. And then I'm going to investigate the probability of winning a competition, the probability of me doing a perfect game where I score 300, or an extension. I propose a potential extension for my maths IA. So you'll see when I actually go through my real maths IA that I didn't end up doing all of these. I stopped here because this ended up being enough content for my whole IA. But you can see that there was so much more to dig into in terms of this topic compared to the original juggling IA, which didn't have much going for it. So yes, that was like my new proposal. So if you're figuring out a topic and your proposal looks something like this, and you are already able to anticipate some of the issues you might have, and you're, like having this like really good reasoning as to why you would do the things that you do, then like that's probably a pretty good sign that the IA will turn out pretty well. And doing all of this planning beforehand is going to make it so much easier when you're writing your IA, because you're basically just following instructions and steps from your past self, and you just have to go through the motions. You're like the robot controlled by your past self. Whereas if you don't have a plan, then you're just kind of like making it up as you go along, and it's a bit scary because you don't know what you're going to do next in your IA. So that is, I had done my proposal. So then in terms of actually writing the IA, I found that it was really easy to get lost in the maths itself. And so I found that it was the easiest way to kind of keep everything clear in my mind and not get confused about what I was doing was to write each step. So the steps that I had in my proposal, write them out on a separate document. So here I was finding the probability of a frame score, probability of explanation, spreadsheet, blah, 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 all of this. And what I found this helped with as well, so it kept things separate, but also it helped me to finish one section and just move on rather than constantly finessing the first section. So I find when everything's in a big document together, then I always feel like I want to reread the first page before I keep going with anything else. And that means that the introduction and like the first page gets super good, but then all of the other pages are kind of like, not so good. And like, you never make much progress that way because you're constantly like rereading the things that you've already done rather than producing new content. So I found that separating it out was a good way to kind of approach that writing process. Also, on these individual documents, you can kind of see here, I'm using the comment section in Word to write out those little notes, like justifying why I'm doing what I'm doing. And this is going to be good for later when you have to explain these things, and also when you are talking about challenges and having to reflect on those things later. You're going to have these like this whole history of things you had considered with regards to this particular portion of your maths IA. So that's very helpful as well to kind of keep track of those things throughout. Because again, like I said before, you're going to forget them later. Once you've actually completed the maths, you're going to be like, oh, that was easy. And then you think, oh, how did I actually figure that out initially? I don't know. So that's writing that IA. And then also on the individual pages, if you're using Excel, then at least for me, I ended up with these massive Excel spreadsheets that were really hard to navigate. And initially, I gave these titles to the tables that I had in them that I thought were so intuitive. But by the time I had like 10 or 12 different massive tables of results, then the titles were no longer intuitive because they were all like probability of bowling frame score, probability of bowling pin score, or something like that. And I'm like, what's the difference between a pin score and a frame score? I don't know, past Ashley. Confusing. So the way that what helped me was to insert screenshots of my Excel spreadsheets into the individual documents below the explanations to which they correspond. So here is like my explanation of like the different roles and like the different probabilities. And then here is the part of my Excel spreadsheet where I actually did those calculations. So for me, obviously in my final written out documents, then I didn't include any of these screenshots. It was more so just for personal reference to help me kind of navigate those spreadsheets and not get lost in terms of like, what am I actually looking at right now? So after I had completed those individual documents, I had written out drafts, which for me is just like code for like, this is like the final like compiled document now, rather than just sort of like individual steps. So piece by piece, I would copy and paste the individual explanations into that central document. And that meant that, yeah, as I was putting them in, then I could kind of slowly assess as I was copying and pasting them, whether I needed to add like little linking sentences to make them make sense and all flow together as a cohesive document. So that's what I did. I kind of put the first couple into this first draft, and then the next couple into this second draft, and then the third, and then like, I slowly built it up until it was all of them. And then I got feedback from my teacher on this sixth draft. So I just kind of wanted to have this included in here to show that I think I kind of mentioned something similar in my 45 video, but when you're presenting your IA drafts for feedback, then you always want to present the very best of what you have to give, because if you present a draft with a whole bunch of mistakes that you could fix yourself, then your teacher is only going to highlight those most obvious mistakes, because they're going to be like, oh, this IA has like lots of issues in it. Let's just fix like the most glaring ones to begin with. And so you won't get the really valuable feedback because you're only getting feedback on the things that you yourself could have already picked up, and you won't know that anything else is wrong, like the more complex stuff, like structural things, or there's an issue with your reflection here, or that piece of maths isn't quite right. Like they're more so going to be looking at like, oh, you didn't define any of these variables. There's a random graph in the middle of your page. Like, what are you doing? So make sure that you've really finessed your draft to the best of your ability. before you give it to your teacher for feedback, because for the maths IA especially, I think there's like, I got such a valuable feedback. Even when I thought what I was submitting was like, I was like, this is the best thing that could ever make it. I got heaps of feedback from my teacher to be like, change this, change that. You need to include this here. And I was like, wow, there was so much more that I needed to do. So definitely do your best before you give it to a teacher. So that is the end of like the little explanation of how I went about everything. So now this is the final section where I'm just going to be going through my IA, which I've annotated in terms of the marking criteria, which will hopefully, like I've said here, give you an idea of like how to structure an IA and also how to incorporate the components of the marking criteria into an IA. So let's do that. So here is my IA, probability in bowling. And also the unannotated version of this was also already on my the Google Drive that I have in the description, linked in the description of all of my videos, but I'll also upload after this my this annotated version and then also the PowerPoint that I just went through. So this is my Maths IA, and you see I've kind of color coded my highlighting in terms of the different marking criteria. So mathematical understanding, that's Criterion E. I don't know why I called it that. Communication, reflection, personal engagement, mathematical presentation. So the introduction. So I kind of start with this, with my rationale. Why have I chosen bowling? Which has to begin with, what is bowling? So I've kind of contextualized it within the fact that, you know, for teens, a bowling alley is a fun place to relax with friends. They're most concerned with enjoying the activity than the actual scores. However, when playing competitively, one is constantly tracking one's own scores and those of one's competitors. I experienced this when my primary school offered weekly bowling as a specialized sport. Personal engagement, yes. To crawl up the leaderboard, I learned which balls to use, how to hold them, and the right way to bowl. As I learned, I watched my average scores slowly increase. As much as bowling is a fun sport for teenagers and families, it is also a skillful game played seriously at an international level. To win, one not only has to improve one's own scores, but also outperform the other competitors on the day. As explained by the World Bowling Organization, bowling is an easy game to play, tough sport to master. So again, I'm giving context, my rationale as to why I'm choosing bowling. Why is bowling a significant topic to look at? It's because it's not only interesting to me because I play, you know, I've bowled in the past and I enjoyed it, but also because it's this serious international competition, and therefore my findings would have relevance to these international athletes. Reflecting on my first-hand experience of improvement through training made me consider what chance I, not having bowled regularly for many years, would now have of winning against a professional bowler. This is the aim of my Maths IA. The central question of what probability would I have now. And that's because based on my plan before, whether I would be able to beat a professional bowler was kind of the final step. I would need to calculate all of these other probabilities, my probabilities, their probabilities beforehand. But the final step and the culminating question that was all for the purpose of answering was, would I be able to beat a professional bowler? Or what's the probability of me beating a professional bowler? Also notice the fact that I'm using the word reflecting on my first-hand experience. So I'm really drawing attention to the fact that firstly, that it's personal engagement because it's first-hand experience, but also I'm reflecting, reflecting. Give me those marks for reflection, please. That's what I'm doing there. So the aim of this investigation is to examine the probability of obtaining certain scores depending on one's skill level and hence beating an opponent, in this case, the professional bowler. And then this is kind of like what I need to figure out, obtaining certain scores depending on one's skill level in order to figure out this final question. This particular aspect was chosen as this investigation's results could be used by aspiring and competing professionals alike to determine their probability of success in a certain competition. This could inform not only the competitions they enter, but also help with goal setting for training programs. So you can see that I'm kind of reflecting on why have I chosen this aim in particular? Why would this be helpful given the context of bowling that I've explained up here? So that is my introduction. I've given my rationale and I've also presented my aim, and I've also done a little bit of reflection sprinkled in. So we now have to start the investigation. Now, we can't jump into an investigation about bowling without me first explaining the basics of bowling, because you can't just assume that the marker, your teacher, but also the IB moderator is going to know anything about the topic that you're talking about. And so you need to include the research and the information which is going to be necessary for them to understand the maths that you're doing later in your investigation. So for me, that was, establishing what is 10-pin bowling. I'm going to be using the term bowling to refer to 10-pin bowling throughout this investigation. I explained the scoring system with 10 frames, how you get a point knockdown, how you get extra point bonuses if you get a strike and a spare, and all of these things. I just explained like the scoring system of bowling because that's necessary to be able to understand my maths later. So that is that. Then I move on to figuring out the probability of single roll scores. So you can see for the communication criteria, then I'm really like, it's logical and coherent because you can see clearly how I'm moving through the structure of my IA. I started with my introduction. I then established how bowling is scored. I then established the probability of single roll scores. I then do the probability of frame rolls. I then do the probability of frame scores. I then do the probability of frame scores with scoring bonuses. And then eventually we do the probability of game scores, and then the skewness of probability distribution, and then normalizing the distribution through a transformation, and then the probability of winning against a professional bowler. So you can see I like built up really logically from individual bowls to individual frames to an individual game to winning against a professional bowler. So that's just kind of like an idea. When you're thinking about how to use your headings, try to think about how you can move from sort of the smallest components and like the equations which are associated with that, and then try like move to bringing the big pieces of your IA together in order to create sort of a logical structure. So for the single roll scores, what is important here? I won't go through everything. You can see I've kind of underlined here. Again, I'm using those key terms of I realized on reflection, I was first considering this, so really highlighting the fact that I'm reflecting on this process. Here we have an example of the mathematical presentation. Probability distributions list the probability that each possible value for a variable occurs. So I'm giving just like a textbook definition of probability. Again, textbook definition down here, probabilities are independent when the probability of one event's occurrence doesn't affect the probability of another event's occurrence. And then I've also explained it in the context of bowling here. So that is kind of that section there. So yeah, I've just to look at this first section, what I'm aiming to do is find the probability of single roll scores. I don't just jump to this section here and say, well, single roll scores are independent probabilities, therefore I'm going to use this formula and therefore I'm going to calculate them. No, instead I started by reflecting and saying, well, at first I thought that it would be a simple process of taking my game scores and creating a probability distribution. However, I soon realized that in the latter part of the exploration, where I was calculating the probability of beating a professional competitor, that would require the probability of extreme scores, which were unlikely to be attained in the small experimental sample. So therefore, I'll skip through a few things here, but therefore the investigation will begin by breaking down bowling to its most basic level, the individual bowls. So I'm going through, well, I considered doing it this way. However, after a bit of reflection, I realized that I can't do it that way. So therefore, I'm going to approach it from the probability of single roll scores, and then I jump into my actual working out. So we have things here. Look, I'm introducing my variables there, just in brackets. I'm explaining the context of the equations before I introduce them. So I'm not just chucking this random equation in and being like, oh, I'm using independent probabilities. Here's a formula. I'm introducing it, saying the probability of knocking down a certain number of pins in R1, roll 1, could be calculated using this formula, and then I define all of the variables in the formula. Here you can kind of see some, reflection on saying, and on accounting for how the theoretical probability doesn't account for how a player's ability makes the probability of some scores higher than than others, in orders that reflect that the pins often knock down other pins in their vicinity, making certain scores more likely than others. For these reasons, using theoretical independent probabilities would be inappropriate. So again, that's that kind of weighing up the strengths and limitations of alternate approaches. Then, you know, it kind of shows that I took that time to reflect on, oh, like, could I just use the theoretical probabilities? And then I was like, no, I can't, and this is why. So again, just analyzing why you can or cannot do something, or why you did do something a particular way. You can see here my referencing to a figure. So therefore, experimental probabilities we use to form a probability distribution. Figure 1. And then here, figure 1, with a descriptive title and column headings there. So it's all really easily identifiable, and my table links in with my paragraphs as well, rather than just like, imagine if I just chucked this in here without this title and without this reference here. Even if I chucked it in with probability distribution of roll 1, I've just come out of, this means that there were effectively 11 frames in these 4 games, and then all of a sudden you have a table saying probability distribution of roll 1. Like, that doesn't make very much sense. So like, that's why it's so important to have these figure titles and then referencing those in your body paragraphs where it's relevant. This also contributes to the marking criteria of having multiple forms of mathematical expression, because it's a probability distribution. And obviously this is a very succinct way to present that like probability information. So you would get marks for being concise there as well. So then probability of frame rolls, you can see I have another table, another probability distribution here. So I get another multiple forms of mathematical expression. I then have without scoring bonuses. Again, you can see that I'm using my brackets here in order to reference the appendix, and also notice the fact that I say the like the probabilities, they were calculated as displayed in figure 1. So I have some sample calculations here, and the full calculations are in appendix 1. So they don't need to see my calculations for every single frame score in order to understand my method. So that's why I can put those full calculations in my appendix, but I still need to include a table of sample calculations so that they can understand what my method was to begin with. Moving down here, this can be helpful as well to include sentences like this, like thus frames and score domains affected similarly were addressed together. So almost like it's kind of like a meta discussion of your IA to say like, this is how I'm going to be organizing my IA just so that you're prepared for it and can like follow easily. You can see I have more like sort of maths things here where I was working out the probability formulas and justifying why they were the case. And here I have some like reflection on, one may think that because of the 10th frame extra roll bonus, it would require a different formula. However, within this domain, the only 2 options are a strike followed by 2 bowls or a spare, blah, 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 blah. There was a whole justification for it. But again, it's like, this was my initial assumption. However, like, this is not the case because of these things. And that's why I've done it. Why have you done the things that you've done? Because of this reflection. Again, labeling my variables. Okay, so this was a big issue in my maths IA that I wanted to talk about. So I had this issue here where I finished my calculations for the probability of getting any of my frame scores. So like within a bowling frame, in 10-pin bowling, the maximum score you can get is 10. So that's F10. And then I think this was the, oh, I don't remember what this was, this part here. It's been so long since I've done my IA, obviously. Oh no, sorry. This is the maximum score that you can get within a frame in bowling is 30, and that's by 3 strikes in a row. And then these frames within 10-pin bowling, then you have 3 goes, like 10 frames where you're trying to bowl down the pins. So like you have 20 bowls overall, 2 for each frame. That's what this is talking about. So it's kind of like the probability of scoring 0 for frame 1 is 0.0122. So that's what this whole table is. the issue that I found was that probabilities, at least probabilities of like events which are, what's the word again? Opposite to one another. Like if one thing occurs, the other thing doesn't occur. Complementary probabilities. That's what I'm searching for. The word that I was searching for. The sum of complementary probabilities is supposed to be 1, because the probability that an event occurs and the probability that an event doesn't occur should be 100%, because you've covered both options there. However, when I added up my probabilities for this table, then I got 1.112 and 1.089. So like basically I didn't satisfy this test that I had set out for myself, where I was like, oh, I'm going to check whether my probabilities are correct, because if they're correct, then they should all add to 1. And then they didn't add to 1. And I was like, oh, this is very bad, very, very bad. But after a while, I figured out that they were actually ratios that I had calculated. Like the fact that they didn't all add to 1 meant that they necessarily weren't probabilities. And so then I figured out that they were just values in the distribution, which were like sort of ratios in ratio to one another. And so if I divided them all by a certain value, then that would get the probability. Obviously, me explaining it now doesn't make much sense. And to this day, I'm kind of like, I don't know if that was legitimately correct maths. This is what I was saying before about that Criterion E, where like whether your maths is correct. They care more about your justification and why you're doing the things that you're doing than whether it's like 100% correct. So like I might have made a small error here. I'm not totally sure. My teacher didn't say anything about it, so I don't know. But I might have made a small error here, but it didn't drastically disrupt the flow of my mathematics, and it didn't give me unreasonable outcomes at the end. So therefore, it would still be considered correct, even if, I don't know, what I'm doing is actually a little bit dodgy. So that's this section here. So that was like a big issue that I overcame. You can see there's a big reflection section here in light blue, where I'm saying like I ran into this error, I figured this out, therefore this is what I did to solve this issue. So if you run into any big issues like that, like try to keep a log of the things that you're doing and why you thought the way that you did, so that you can have this kind of big reflection section. Then we have the same kind of thing here. It's good to signpost the things that you're doing, just like at the beginning of this section, to kind of say the frame score probabilities we use to find the game score probabilities, like to kind of say, hey, that's what we're doing in this whole section here. Again, another form of mathematical expression. Once I had figured out the game scores, then I put them into a probability distribution with the axis labels, the figure label, appropriate scale, all of that jazz. More reflections here, more definitions of what a standard deviation is, what is the significance of a low standard deviation. Talking about skewness now, because my distribution wasn't perfectly normal. That was a big issue. I was like, oh, what am I going to do if my distribution isn't perfectly normal? Initially, I thought I could use the central limit theorem, but then that was not working. So then I had to figure out a different way to do it. So then I found this skewness formula online and decided to apply that. So anyway, that was just me adapting the skewness formula to the context of my investigation. And then I normalized the distribution. I kind of transformed the x-axis values so that it would become a normal distribution. Again, the maths here is not that important, because obviously this was something that I spent more than 30 hours on doing, but the important concept is the fact that like I'm facing this issue of, okay, I've mapped the probability of my game scores. I am calculating its skewness in order to assess whether it's a normal distribution or not. Alas, I find that it is not a normal distribution. Therefore, like I have this whole section discussing how I'm overcoming this issue, reflecting on why I'm approaching it the way that I am approaching it, and then coming up with this new graph. And kind of, again, interpreting the graph here, like although the distribution visually appears negatively skewed, this is simply because of the positioning of the mean of the scale. So kind of reflecting to say, yeah, it looks this way, but there's a reason for that. And then finally, once I had created my probability distribution, then I applied my probabilities to winning against a professional bowler, and there was a big issue here in terms of only having game scores, and so I couldn't use the same process that I had used for myself, where I had access to both my roll scores, which I kind of added up to give my game scores, whereas online I only had game scores available. So I kind of discussed the limitations that that placed on my investigation. And like, that's kind of a good note. Like, if something isn't available to you, or if you're having some issue with processing the data, like, it's okay to kind of pivot your approach or use an approach which is like less than optimal, and just acknowledge, like, I had to use this approach because something else was happening. So for me, it's like I had to use this other approach because only the game scores were available. Ideally, I would like to do it the same way that I calculated my probability distribution, but it is not possible. So that was just another big chunk of reflection here. So you can see how that reflection is really integrated throughout the IA. And then I use the t-test to figure out the probabilities of me winning over this American player, I think, McEwen. Yes, an American bowler. So then I figure out this probability, and the probability of me winning is 0.00064. And then again, I calculate, I was like, oh, now that I have this probability, I can figure out the number of games it would take me to win, which was 1,562.5. So a lot. So then when it comes to your conclusion, the format, I would say, is first talk about what the main takeaway is from the results that you see. So for me, it was, this exploration has demonstrated how bowling's objective scoring interacts with skill level to determine the likelihood of obtaining certain scores. So that's me kind of like rephrasing my aim in order to demonstrate I have addressed my aim through this exploration. This principle was demonstrated through the extremes of an amateur and a professional. So that shows a little bit of like my creativity or my personal engagement, like this idea that I had to really demonstrate this characteristic of bowling through putting me up against the #1 bowler in the world at the time. So that's kind of a little bit of personal engagement there, to have thought of this question or this approach to answering some questions about the probability of bowling. However, the same process could be applied to any proficiency level. So I'm also thinking about the applications of my IA to other people. That isn't specifically one of the marking criteria for the maths IA in the same way that it is for the like science IAs and other IAs. But I think it's still nice to put it in to kind of say, well, if this is the broader context of bowling, then like it could be used in these ways. We have a little bit of reflection here. What have I learned? I've gained a new appreciation for elite bowlers, as calculating my minuscule chance of winning against a professional underlined the disparity between our abilities. However, again, this is like, oh, I've changed my thinking. However, these results contradict my gut reaction that it would be impossible for me to beat a world-ranked athlete. This is a hopeful perspective for aspiring bowlers that if they compete in enough competitions, the odds may eventually fall in their favor. So how has my understanding of the topic of bowling shifted as a result of using maths to investigate it, is really what I'm reflecting on there. And then finally, I finished my IA with a reflection on the limitations of my approach overall, to kind of say, well, the human aspects reduce the reliability of such mathematical explorations. Using experimental probabilities, one would think that larger samples would provide more accurate values, but for bowling, the larger the sample, the more one has practiced, and likely the more one has improved. Thus, earlier scores may not reflect one's current skill level. Therefore, as the sample grows, calculated probabilities become less accurate in representing the present moment. So that was actually I remember a reflection that I had written down as I was actually bowling over the course, like when I was collecting my scores. I was like, I'm improving a little bit at the beginning, and then towards the end, I'm like so tired because I've bowled so many games. And so then now my scores are terrible at the end. And I was kind of reflecting on the fact that, oh, you know, normally if you're thinking about experimental probabilities, like flipping a coin, the more that you flip the coin, the closer those experimental probabilities will align with the theoretical probability. But I was like, that's so not what's happening with my bowling. And so then that was something that I wrote down, and then like I saved it for later, and then I was able to include it in my final IA. So just whenever these little reflections or thoughts come to you, just pop them down somewhere and make sure you have them saved away, because it really sort of I think takes away a lot of the heavy lifting that you have to do at the end to come up with all of these reflections, because instead they've just sort of like popped into your mind as like questions of like, oh, that's a little bit weird, as you've gone throughout. So you can see as well, just here, I have like a whole bibliography from where I was like investigating not only bowling and getting those scores, but also like looking up the T-score formula and the skewness formula, just because that isn't like part of the IB course. You have my calculations that I gave the sample calculations for before. And then you have like my probability distribution, the before dividing through. So this is like the one where it was actually ratios and not probabilities. And then I have my probability distribution of game scores. So you can see that this would have been way too long to include within my IA, but I can just say like I calculated this probability distribution of scores. You can see it in this graph here. So I have represented it so that the marker can understand what I'm talking about, but I don't have to include it as a table form in my IA. I can just put that in my appendices. And then, yep, that was her scores, and that was my IA. So that's pretty much everything. I hope that this has been in somewhat helpful. I know it was a little bit rambly because it's a bit less scripted than my usual videos, and obviously this wasn't edited. I've just done it all in one take, but I hope you've still been able to get something valuable from it. And at the very least, you know, you can look through the PowerPoint that I wrote out and this IA, which I'll have uploaded to the Google Drive. And if there's anything that's still unclear, then like feel free to ask in the comments below, and like I'm sure like other people can also, you guys can help each other out, because you guys actually know stuff too and have different perspectives on the maths IA. So it's good if it's not just me answering the questions or giving my perspective, like you guys all have something to offer too. So yeah, I hope that's kind of cleared up some things about the maths IA, and hopefully you'll stick around for some other IB videos. Yeah, okay, thanks for watching.